In this video, I'm going to be upgrading this M1 Max Apple Mac Studio from its original 512 gigabytes of storage to its absolute maximum of 8 terabytes. Now, for those of you who have looked into this process in the past, you would know that unlike all other Apple Silicon Macs that have soldered storage, I guess excluding the M2 Mac Pro, the Mac Studio has its storage on removable modules. Now, with that in mind, you might think that unlike the ones with soldered storage, in this instance you can just simply replace the storage modules with larger ones, with ones of larger capacity, and simply upgrade the system that way. Well, if you've taken a look at previous attempts of other people doing this and documenting their experiences online, you would know that in most cases those attempts have not been successful. And the reason for that is because despite this machine not having soldered storage, you still have to treat this storage as if it were soldered storage, if that makes any sense. So if we go ahead and take a look at one of the storage modules from the Mac Studio here, you can see that it is a pretty small module here, obviously proprietary, but you can see it's simply a board with 4 NANDs on it. Now, if you've ever seen any normal SSD, you would know that an SSD has a controller and NANDs on it. And the reason that this storage module only has NANDs on it is because, like every other Apple Silicon system, the storage controller is part of the M1 SoC itself. So that's why you can't simply just swap these around and expect them to work. Now, if you've seen any other previous videos of mine, you would know that I have experimented with doing soldered storage upgrades in many other Apple Silicon Macs, and upgrading the storage in the Mac Studio is essentially the exact same process as upgrading the storage in those systems with soldered storage, and you must treat it as such. So with that in mind, what we need to do is somehow get 8 blank 1 terabyte NAND chips into this machine. And the reason I say blank, and if you watch my previous videos, I go into this in a bit more detail, but essentially you must use brand new blank NANDs that don't have any specific programming on them in order to upgrade one of these systems. And the reason for that is when blank NANDs are installed onto the system, the restore process will program them appropriately for the configuration that they're installed in the system. So the next hurdle we have to get over here is the actual board itself. So if we go ahead and flip the Mac Studio over here and take a look inside it, you will see that down here in this area we have got 2 slots. So you can see right here we've got 1 slot with a storage module installed, and on the other side we've got another slot with no storage module installed. Now, as I mentioned, we have to get 8 1 terabyte NANDs into this system to achieve an 8 terabyte configuration. Well, how exactly are we going to do that? Well, we need a second NAND module, which obviously I have right here. But as you can see, this is a factory Apple NAND module, which not only are extremely hard to find, but when you can find them, of course they already have NANDs on them, which we're not going to even be using in this instance, but they're also extremely expensive. And that is where a good friend of mine, Gilles of Polysoft Services in France, has come in. So as you can see here, we've got a fresh, brand new storage module PCB here, completely custom designed by him. And as you can see, I've actually got 2 of them. And you can see that compared to the original module here, they look almost identical. But you will notice a few small differences there, here and there, both in some circuit design of the board, but if you take a really close look here, you can see that he's replaced this little data matrix here with his logo, so I found that kind of funny there. So in this video, I'm going to use these 2 modules to upgrade this Mac Studio. Now, having brand new modules like this is a huge benefit because not only can I use them to upgrade machines that, say, people send to me, but I can actually simply solder NANDs onto these, send them to someone else, and they could simply install them, do a DFU restore on the system, and have a upgraded system. Of course, once with blank NANDs on here, you can put these in any configuration, at least one that's supported by the actual system, and then just upgrade it yourself with these new modules. So before I begin the upgrading process here, the first thing I want to do is I want to boot the system up as it is right now and do a disk speed test with the single module installed, and then we can compare that result with the upgraded system after we install both of these modules with, of course, 8 terabytes of total storage, and see if the speed changes at all. I don't really expect there to be that much of a difference, but I do expect to be at least maybe somewhat of a difference. So let me go ahead and get this machine hooked up to a keyboard, monitor, and mouse. We'll boot it up and take a look at the speed of the current installed storage. Alright, so as you can see here, I've gotten the machine all booted up and connected here, so let's go ahead and check out about this Mac. And you can see there that, like I mentioned, this is an M1 Max Model Mac Studio with 64 gigabytes of system memory installed. My friend who sent this to me did install the Sequoia beta on here, so it is running that. But if we go ahead and go into more info here, you can see that the storage is currently, of course, 512 gigabytes. So of course, that's what we are going to be upgrading in this video. But as mentioned, the first thing I want to do is do a quick disk speed test here. So let's go ahead and get out of this, open up the tool here that I intend to use, and we'll go ahead and just run the test now. So you can see that we're getting about 6,000 megabytes per second read or write speed, and a little under 5,000 megabytes per second read speed. So that's our baseline numbers here. Like I mentioned, I don't think that's going to change all that much, but it might. So I definitely want to get that, and so we can do a comparison after the upgrade and see what it does. So with that, I'm going to go ahead and get it shut down. And then we'll just start working on those new NAND modules. Of course, we don't really need to do anything with the Mac Studio itself at this point, but we do need to, of course, prepare some new NANDs to be installed onto those modules. So with that, I'll go ahead and begin the process of beginning to reball some 1 terabyte NAND chips. Alright, so as you can see here, I've gotten my new set of NAND chips out here, ready to begin reballing them. And these, of course, are brand new blank chips, as I mentioned, and are, of course, 1 terabyte in size. And in particular, in this instance, I am using part number KICM223 NANDs, as you may be able to make out right there. And of course, like I mentioned, we have 4 NANDs for each module, and the total after installing all 8 will of course be 8 terabytes. Now cost-wise, these NANDs cost about $500 for me to get, and when you compare that to the $2,400 that Apple charges to upgrade from 512 gigabytes to 8 terabytes when you buy one of these Mac Studios new, that is a huge amount of cost savings, at least in parts alone here. And even with the labor involved to do this upgrade, it's still going to end up being less than half of what you pay to have Apple upgrade this for you or buy one new with this amount of storage already installed. And one last thing I want to mention here, if you take a look at the NAND module that I've received from Gilles here, you can see that on each set of NAND pads here, there's one pad that has been covered with some solder mask. You can see the same is true on the other side of it as well. And this, of course, is not the final design of this particular board, and he did make one mistake where he accidentally tied this pad, which is supposed to be a no-connect pad, to ground. And while in most cases that usually doesn't cause any problems, I guess there is a function of the NAND that is affected when you tie this to ground, so that has to be blocked off and not connected for it to work properly. Now, in addition to this solder mask applied on the pad itself, I am also going to remove the solder from that particular pad of each one after reballing them. That way we can be certain that no issues will arise. So with that, we're just going to begin the reballing process here. And of course, the first step is to take each chip and align it to the footprint on the stencil here. So the way I'm going to do that is just use some Kapton tape and simply place the NAND on it like so. And then we can align it to the holes in the stencil. And just like that, the NAND has been aligned to the holes in the stencil, and we can now begin the reballing process. So in order to do that, I'm just going to use this tool with some solder paste on it, as you can see there. And then we're going to simply take that and press it into all the holes on the stencil. And I usually go over it a few times just to make sure there's an even amount of solder paste in each hole. And just like that, we're ready to start heating. So in order to heat, I'm going to turn my hot air on to about 300 degrees Celsius. And now with that up to temperature, I'm going to take this pair of angled tweezers and press down to ensure that the stencil stays fully seated against the chip, and then we will start heating. And with all this solder paste now melted onto the respective pads, we'll go ahead and remove the chip from the stencil. And then I'm just going to apply a little bit of extra flux. And heat it one more time. And now, of course, the last thing I want to do is remove that one pad, or at least remove the solder from that one pad that is a no-connect pad on the board here. So in order to do that, we just need to make sure we get the correct one here. And it looks like pin 1 is going to be right there. So it'll be kind of inverse here. So it'll be that pad right there that we need to remove. So in order to do that, I'm going to kind of cut my solder wick here at a little angle, and then we will take that, get the chip up to temperature, and just use the solder wick to remove it, just like so. So with that all done, now we just need to repeat that process 7 more times for each of the other chips, and then we will be ready to begin soldering them onto the new modules. Alright, as you can see here, I've successfully reballed all 8 chips. You can see that I've removed solder off that one pad on each one. And you might also notice that I've removed the flux from each chip as well. And the reason I've done that is because with these large pitch chips like this, with the solder pads spaced out pretty far from each other, when you reball these with solder paste, it tends to leave little pieces of solder balls kind of floating, or little pieces of solder floating in the flux on the chip. And you want to remove that, because when you solder that on the board, there's a chance that those tiny little pieces of solder could cause shorts between some of the pins, which obviously you don't want. So with that all done, the next thing we need to do is simply solder each of these chips onto both of these modules. So of course 4 chips on one module and 4 chips on the second module. So with that, we'll begin the process of soldering those chips onto the NAND modules. Alright, so in order to perform this soldering, you can see I've got one of the modules in this little board holder here, which helps hold it in position and keeps it from moving around on me while I'm soldering. So the first thing I'm going to do is I'm going to get the board, get a little bit of heat in the board, so preheat the board a little bit with my hot air. Then we'll apply some flux, and then we can simply solder our newly reballed chips onto it. Alright, so I've got a nice amount of heat in it now, so now we should be able to just apply flux and it'll kind of just spread out as a liquid like that. And with that all done, we can simply take two of the chips, doesn't matter which ones because they're all blank, unprogrammed, and simply place them into position. So get them pretty well aligned like so. And now we'll simply take the hot air and solder them onto the board. Alright, and now those two are soldered on successfully, so now we just need to let it cool down just a little bit, flip the board over, and solder the two on the other side. And just like that, one module is done. So now I'm just going to repeat that same process with the second module here, and at that point, everything will be ready to go. Alright, so as you can see here, all 8 NANDs have been soldered on successfully, and everything looks really, really good on these cards. As you can see, there is still a little bit of flux on there, but I will clean that off once I test these and make sure everything works as expected. But soldering wise, all the chips look to be soldered on pretty well. The only thing that was a little bit concerning, you might be able to make it out with this one, is the piece of enamel, or the piece of a solder mask that was applied to that one pad was a little bit tall, and it's kind of pushing the chip up a little bit on this edge. But the solder balls are pretty big, so I don't think that will be any issue in this instance. So now all that's left to do is get these modules installed in the Mac Studio, perform a DFU restore, and see if everything works as expected. So with that, let's get them installed. Alright, so as you can see, I've got the Mac Studio relatively disassembled here, so now we just simply need to remove the original module. Just like so. And then we can take one of our new modules, doesn't matter which one at this point, and install it into the slot. There's one installed, and somewhat annoyingly the second one is missing its screw, so I guess we're just gonna have to put it in there with no screw at this point. But these are very secure slots and it won't make a difference really at all. And there we go, fit right in. So that's ready to go. So now let me get the power supply and the little frame put back in, and we'll be ready to give it a test. Alright, so I've got everything connected here. I've got another Mac connected to it, an M1 MacBook Air via USB-C. So now all we need to do is boot the device into DFU mode. And in order to do that, you simply hold down the power button while plugging the device in. And as you can see there, the device is now in DFU mode with the little LED on the front flashing amber. And you can see that the M1 MacBook Air over there has detected the device. So now we simply need to restore software onto it. So to do that, we're just going to hold Option and select Restore Mac. I'm going to go ahead and select this macOS Sonoma version 14.5 IPSW here, and we'll select Open. Alright, and the restore process has begun here. And we've got a video signal on the display there, which is a really good sign. And yes, the restore is progressing with the custom 8 terabyte modules installed. So now we simply have to sit here and wait, and in theory, everything should go according to plan. And just like that, the restore has completed successfully. And it chimed. And there it is. Look at that. So let me go ahead and get macOS set up here, and then we'll take a final look at the specs and run the speed test. Alright, so as you can see, I've gotten macOS set up here, so let's take a look at About This Mac. So you can see, of course, it is the same system, the same M1 Max Mac Studio with 64 gigs of RAM installed. So now let's go ahead into more info here. And if we scroll down, look at that, 8 terabytes of internal storage. So let's check out System Report, NVMe Express, and there it is right there, Apple SSD AP8192R with a total capacity of 8 terabytes. So that is now a fully maxed out, at least storage wise, M1 Max Mac Studio. We can take a look at disk utility as well, which should show us the same thing. And yeah, there we go, 8 terabytes of onboard, or I guess internal storage. So let's go ahead and get out of all this, and we'll run the speed test. Now, like I mentioned, I don't really expect there to be too much of a difference here, but definitely should try it at least. Okay, so it is a little bit faster, especially in the write speed, but the read speed is more or less the same, maybe slightly faster, but overall not a massive difference in speed, which is about what I expected. So with that has been the successful upgrade of this M1 Max Apple Mac Studio from its original 512 gigabytes of internal storage to its maximum of 8 terabytes of storage. And like I mentioned, the total cost of this, for the chips at least, was about $500, which is a very, very good deal compared to the $2,400 that Apple normally charges for this upgrade. So I want to give a huge thanks to Gilles of Polysoft Services once again for designing these awesome boards. Without them, this upgrade would have been a lot more difficult. We would have had to remove all 8 of those underfilled chips off of those factory boards, and it would have just taken a whole lot longer, and not to mention be even more expensive with those hard to find boards. So very, very thankful that Gilles took on the challenge of reverse engineering and designing a completely custom NAND PCB module for the Mac Studio. So with that, I hope you enjoyed this video.